Hey, welcome back, guys. Today we're going to be looking at our last section of notes here in the kind of probability and statistics unit. We're going to be looking at probability in society. That's the overarching title here. It's going to be a little more mathy than some of the past ones. We're actually going to look at how people calculate things using probability and what it's used for and some examples of it. But let's start with a little bit of a refresher here. You're a town planner. You need to know if people want walking trails or bike paths along the nearby river. Now, there's 15,000 people in town. That's way too many to talk to. You're going to survey 1,500 of them. So first, identify the population. So again, population can be any group of people that you're interested in. And in this case, we're the town planner. We're basically just interested in people in town, right? So we're interested in all residents in town. That's who we want to hear from. That's who we want to talk to. That's what we're interested in. Now, we know we can't talk to all of them. That would take too much time, wouldn't really be worth it. But that is our population currently, all residents in town. One little side note on population, sometimes it's also handy to specify a time. So, for example, if you wanted to talk like goose populations, you might want to look at like the population of geese in Niverville in the summer. Because if you look at the population of geese in Niverville in the winter, there's none here because they all went south. So sometimes you do need to specify a time for population as well. Just something to be aware of that I don't think I mentioned before. Question 2. Describe how you might select the sample and how you could conduct the survey. Now, this is a question that a lot of people struggle with a bit, not because it's hard, but because they don't add enough detail. A lot of people say something like 1,500 people, so that's like 1 in 10. So they'd say like survey 1 in 10 people. There, we've got the 1,500. We're good to go, right? Let me just quickly switch over to red here. No, that's bad. We don't want that. There's not enough information. Where did the 1 in 10 come from? How did you select them? How would you get in touch with them? You need to describe. The keyword here is describe, and you need enough information. So in this case, where could I find a list of the 15,000 people in town? Well, I could use a phone book, but that only gets me houses. That doesn't get me everything, right? And everybody. If I'm interested in all residents, I don't just want whoever owns the house. I probably want to talk to the kids too, because the kids are likely to use walking trails and bike paths. So where could I have a list of everyone in people or every single person in town? So maybe I would have to find the town census data. So the census is a survey that the government send out. I think it's like every 4 years. So this might not be totally up to date, but it would get you close. And everyone has to answer, and it talks about how many people in your house, what are their names, what are their incomes, all kinds of stuff. So if I have the town census, I would have a list of everyone in town. So I could use this to select every 10th person. And how am I going down this list? It doesn't really make a huge difference, but you're still going to want to specify. You want to describe it. So let's select every 10th person. Let's just do it alphabetically. So we'll start with the A's, we'll go down to the B's, we'll pick every 10th person. Now, how do we get in contact with them? We will phone each person. So now I could, this is enough information. You could literally go out and do this. You could go find the census information. Pretty sure it's online. You could use it to select every 10th person alphabetically, assuming the names were linked to that data. I'm not sure if it is or not, but I think it is. And then you just look up each person in the phone book and phone them. Or you could even find their address on that census data as well. So that would give you the ability to actually talk to 1,500 people very randomly. This is a much better description of how you'd select the sample. So I'd use the town census and I go to a 10th list alphabetically. And what would I do? I'd phone each person. And just a quick reminder, this one would be called systematic. Never a bad idea. Actually, it's always a good idea to mention the name of the method that you're using. So the systematic survey, where I'm going down a list and I'm selecting every 10th or 15th or 20th, whatever you're doing. The trick to describe is, where do you get your list from and how do you get in touch with them? Is it an email? Is it a phone call? Are you going to go knocking on doors? What are you doing? All right, 3, results of this survey. Suppose 60% of the people preferred bike paths. What prediction would you make about the preference for the entire town, for the town's population? Well, it's assuming that we did a decent job of our sample and it was pretty representative, you would predict that if 60% of our sample wanted bike paths, then likely 60% of the town would like bike paths. Which means that bike paths are probably the way to go. You got a majority here. Most people are interested in that. Now, 4, what assumptions did we make in our prediction? So we're saying 60% of our sample wants bike paths. Why does that mean that 60% of the town wants bike paths? There's different groups of people, right? Well, we are assuming that the sample is an accurate representation of the town. Now, we did things kind of semi-regular or randomly, right? We just called down an alphabetical list. There's no guarantee that we didn't get all people that are part of a cycling club, or we skipped everyone who's part of a walking club, or it could just randomly have happened, right? But because the odds of that are really small, right, of missing every single person with a certain set of interests, so we're assuming in this case that the sample should be an accurate representation of the town. And that's it should be a safe assumption, but there's a lot that goes into that. But generally speaking, when you're trying to move from sample percentage into population percentage, this is the assumption you are always making, that our sample was done right. It's an accurate representation of the town, that the sample itself has no bias. Now, every sample has bias, right? And if you want to you think about this, we got data from a census. Where would the bias be? Well, we don't have any new residents. Anyone who's moved in since the census took place, we wouldn't have their information. So that's a little bit of a bias there. We don't have newer people moving in. Who's more likely to move into a town? Well, it depends on the town, right? But some towns are like young towns and growing towns. You might have missed a bunch of young people who are active. Some towns are like retirement towns. Then you're missing a bunch of old people that might be more likely to walk than go biking. So there is some bias in the sample, but we're going to have to assume that it's close. Otherwise, what's the point of doing the sample? If you're assuming your sample is useless, why are you doing it? You should probably rejig your survey and try to make it better. 5, after hearing other groups' decisions and comments, because of course you always want to, open it up to the town. What do you guys want? Let's talk about it. What are the pros? What are the cons? What decision do you think you would make about walking trails or bike paths? And again, this one is up to you. Would you want just walking trails, just bike paths? Would you want a mix of the two? I've heard people on both sides. Some people say, yeah, just do the bike paths. Like, they're probably more expensive because they'd have to be paved, but 60% of people want them, so let's do it. I heard other people say, why not just make walking trails? Even if it's paved, you can still take mountain bikes on walking trails and then you're good to go. You can multi-use. And other people say, well, try to find a mix. Maybe bike paths in certain areas are really good that are high traffic because you can still walk on a bike path. Or maybe you want walking trails that are in little parks or something that people might walk. So that's an up to you guys thing. What your answer for number 5 would be. Just make sure you justify it. Don't just say, I want bike paths. It has to be, I want bike paths or walking trails. And why is always the important part. So make sure you're always describing your thinking. All right, example 1. We're going to look at some math here. Ruth wants to determine the most common eye color of students. All grade 12 students in 5 out of 7 high schools in a city recorded their eye color. So you got the city, it's only got 7 high schools in the whole city. We're going to survey 5 of those high schools. So we're getting a pretty good chunk of the students. We did a total of 2,300 students surveyed. The results are shown in the table below. So here we go. We got 1656 for brown, 483 for blue, 115 for green, 46 for other. Whether that's like a gray or kind of a mix of the two where you couldn't really tell, you got 46 others. From the results, predict how many of the 7,200 students which are at the local college, so these aren't high school kids anymore, but it's like you go from high school, you might go up into college after that. Predict how many at the local college would have brown eyes. Show your thinking. All right. So we're going to say, here's what we're going to do. For what's the word I'm looking for? Probabilities. For probabilities, you almost always are working with percentages. So always use percentages. And the rule for percentages is, whoa, I didn't mean to do that. It is what you are interested in divided by total. That's an ugly total. Total number. Let's see if I can. There we go. So let's find first the percentage from the high schools that had brown eyes. So I'm interested in brown eyes. What I'm interested in are the 1,656 there with brown eyes. And how many students in total? Well, it said in the question, 2,300. So you grab your calculator, 1656 divided by 2,300. Oh, I forgot one step. That formula is always times 100. So if you just do the divide, it gives you the number as a decimal. To change decimals into percents, you multiply by 100. So it's always 100. There's nothing that'll ever change that. So 72% of our students have brown eyes. So how many kids at the local college would have brown eyes? Well, probably 72% of how many kids? 7,200. Now, I don't know if you guys remember, it's been a while since we talked percentages. What does of mean when dealing with percentages? Of means multiply. So I change my percent to a decimal, and I multiply. 0.72. Oh, that's not a point. Oops. Clear. 0.72 times 7,200. So we would expect at that college 5,184 students would have brown eyes. And show your thinking is just another way to say show your math in this case. We're going to calculate this out. Now, is our prediction reasonable? Why or why not? So some people say, again, this is another one where you get to defend your choice one way or the other. Some people say, yes, there's no reason why eye color would change who's going to high school. And so high school numbers should match college. And others say, well, it might actually not be that good because we missed 2 high schools. And we have no idea what they are like. So you might have, one of those high schools might be like a private school that has a lot of like really high achieving students that are more likely to go to college or university. Well, their demographic then might be more important than the generic high schools. Maybe a couple of these high schools are in really rough districts and just don't have a really high rate of people graduating and going on to college. Maybe a lot of them go right into the workforce. Well, then their results might not make as much of a difference to the actual college numbers. Another thing to consider is, we talked about this before, but a lot of times in areas of town, people tend to congregate with people like them, right? So if you were to look at the population of eye colors in Niverville, it would be very different than if you looked at the population of eye colors in like Chinatown in downtown Winnipeg, right? If you have a high school in Chinatown, you're going to have a lot more people of Asian descent, which means likely a lot more brown eyes. It's more common in that group. Whereas here in Niverville was a lot more people of European ancestry or South American ancestry. And so you're going to have a lot more of blue-green eyes compared to some other regions. So depending on what the general demographic is in terms of who lives in those areas, that could skew your numbers. So if those 2 high schools, because we only looked at 5 out of 7, those 2 high schools are in areas that might be more likely to have blue-green eyes or more likely to have brown eyes, that might skew your numbers too, because those kids are still going to college, right? So some people say, yes, the high school numbers should match the college. We got 5 out of 7. We got most of our high school students, so we should be pretty close here. Others say, no, we missed 2 high schools, and they might make a big enough difference. As long as you justify, as long as you have your reasoning, You should be good to go. Don't just leave it at yes or no. The explain is the important part. Example 2, Mr. Smith gave an assignment worth 30 marks. After marking the first 5 papers, he was concerned the students did not understand the assignment. He predicted, based on those first 5 papers, doesn't look like most students are not going to do very well. And you can see here his papers, a 20, a 15, an 18, a 19, a 19? Oh, it's not a 10. But we're going to find the mean, the median, and the mode for his sample. So first I'll tell you what those things mean, but based on those statistics, we're going to predict the average mark for assignment as a percent. So first thing, mean. When you see mean, it is what most people talk about in everyday life as average, even though average just means the midpoint. And there's a lot of different ways to find a midpoint. When you're talking about what you're thinking, like your average on a test, what you're actually talking about is the mean. And so it is the total of your numbers divided by the number of values you have. And this will make more sense once we actually walk through an example. But it's the total value of your numbers. So you add your numbers together, and that goes on top. So I would add, in this case, the 20, the 15, the 18, the 19, and the 10. And then I divide by the number of values. How many numbers did I look at? 1, 2, 3, 4, 5. So I would take the addition and divide it by 5 because I looked at 5 papers. That gives me the average. Median is usually it's easier to find. It's just the middle number. You put your numbers in order and you find which one is in the middle. And the mode is the number that shows up most often. Now, these are a bit tricky. You're going to learn in further math courses down the road why we use certain ones in certain cases, but I'll give you a brief overview here. Mode is really handy for what's called discrete values, where you can have the number, but nothing in between. It's like tests here would not be a discrete value. You can have a 20, you can have an 18, you could have a 19, you could have a 19.5, you could average stuff out there, right? An example where you might want to use mode would be like starting salaries. Let's say you're going to be a pilot, and you go Google some starting salaries. So pilot 1 gets paid $20,000, pilot 2 gets paid $20,000, pilot 3 gets paid $30,000, pilot 4 gets paid $30,000. So they're all getting paid $30,000. But pilot 5, he works on as a private jet pilot for some fancy guy. He gets paid $300,000. So how much are you going to make at your job? If you were to average those numbers out, 30,000, well, I got 4 of those, plus, what did I say the other one was, 300,000? And divide that by all 5, your average starting salary is $84,000 as a pilot. Doesn't that sound amazing? Pilot's average salary, $84,000. Are you going to make that much? No. You look at the mode. Which one shows up the most often? The vast majority of pilots in this case were making $30,000, and the odds of you getting that one lucky job probably slim to none. So mode would make a lot more sense. Didn't mean to close that. Would make a lot more sense in that particular case. Median is for looking at your middle numbers. Let's close that. And this is handy when you have one, similar to that last question actually, when you have a couple outliers, numbers that are way, way, way bigger for some reason, or way, way, way smaller than some reason. So let's say we're looking at tests here, and there's one student who didn't show up to Mr. Smith's class here for 3 weeks and happened to show up on test day. Came in, sat down and said, yeah, I don't care, give me the test, I'll try it. And he gets a 0. Misses every single question. Now, that would be an unusual mark, right? But that 0 is going to drag the class average way down. So the average mark for the assignment, you probably wouldn't want to include that. So you can either trim it off and then do a mean, or you could decide, oh, maybe I'll just look at the median. I'll just look at what the middle value is and see how that lines up for my students. An average you can use for just about any set of numbers as long as they don't have outliers and they don't have weird, something like shoe size, where I wouldn't want to average. If I want to say which shoe size should I buy, I don't want to average the ones I'm selling because I can't buy a 6.2. You know what I mean? I have to buy a size 6 or a size 7. So mean doesn't always work if you can't have numbers in between. Anyways, here are the scores. Let's figure them out. Okay, let's do the mean first. So first thing I got to do is add all these numbers. 20 plus 15 plus 18 plus 19 plus 18 plus 16 plus 17 plus 23. I probably should have done this ahead of time. Oh, where was I? 23, 24 plus 30 plus 22 plus 24 plus 21 plus 20 plus 24 plus 25. So averages, honestly, when I'm giving you an assignment, I will not be giving you one with this many numbers on it. This is a little bit crazy. Plus 28 plus, because even if you know what you're doing, the odds are pretty good you're going to make a mistake somewhere. Like when I almost punched in 30 instead of, or 32 instead of 23. Or if you lose your place, like I just did. Did I just do the 19? I think I did. Plus 13, plus 28, plus 22, plus 24, plus 20. So if I mistyped one or typed one in twice or something like that while I was chatting with you guys, my answer will be off. So I add them all together, and I divide by how many numbers I have. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 10 times 3. So that's 30. So I divide by 30. And then times it by 100. So the average for this class, whoa, that's not right. Clear that. 649 divided by 30 times 100. Oh, I don't have the times 100. I'm not doing a percentage. I'm finding their mark. Whoops. Yeah, so their average mark is 21.63. There, that's the average mark on this test. 21.63 out of whatever the test is out of. If we go back and look, oh, the test is out of 30. So you could do 21.63 divided by 30 again if you wanted a percent, but that is your average mark on that test in terms of the mean. If you want the median, I need to find the middle number. So I take the biggest number off and the smallest number. So 30 and 13 cancel out. What's my next biggest here? I got a 28 and a 16. So that's my second set. My third set, I cancel out a 28. Oh, and that's 15. Probably should have done the 15 first, but that's all right. Then only really becomes important when you get down near the middle. I'm going to do 2 in a row here just to make it a little faster. Let's get rid of the 28 and the 27. 15 and 17, so I just did 2 more. Let's get rid of, for my next highest ones, 25s and 24s. 1, 2. I'll get rid of another 2 in a row. So the 2 highest and the 2 lowest canceled out. What are my next 2 highest? Lots of 24s. I'll get rid of 2 24s. Get rid of 2 19s. I'm going to slow down a little bit. I'm going to start doing one at a time now. Let's get rid of a 24 and a 19. Get rid of a 24 and a 20. Get rid of a 23 and a 20. Get rid of a 22 and a 20. Get rid of a 22 and a 21. And the middle number I'm left with is a 22. So that's my median, is 22. If you happen to have 2 numbers left, like let's say my numbers were 5, 6, 7, 8. I'd cancel out the 8 and the 5. And if I cancel out the 6 and the 7, I got nothing. So that's no good. I have to leave them both. You basically just look at those 2 numbers and you average them. 6 plus 7 divided by 2. So my median in this case would be a 6.5. So if you happen to get left with 2, that's how you take care of it. You just find the average of those 2 numbers and call that your median. All right, last one, mode. What number shows up the most? All right, I got 2 20s. Probably not it. I saw a lot of 22s, didn't I? 1, 2, 3. All right, so I got 3 22s. I can erase the 20s. I don't need that one anymore. What are 24s? I got 1, 2, 3, 4, 5, 6. Oh, yeah. I got 6 24s. There you go. That's got to be the highest. 1, 2, 2 18s. 1, 2, 3 28s. Yeah, no. A couple of 3 19s. Yeah, nothing else even gets close. So 24 is the number that shows up most often. So 24 is our mode. It's just the number that shows up the most. One thing to be aware of with mode. What is the mode of that set of numbers? Well, I got 2 2s and 2 5s. So you would say in this case the mode is 2 and 5. You can have multiple modes. Flip side of that. What's the mode of this? There's one of everything. In this case, you don't list everything and say they're all the mode because they're all the most common. You just say there is no mode. Nothing shows up more than once. So you can have multiple modes. You can also have no mode. It's an option. But usually for the large enough data set like this is, you're definitely going to have some number that shows up more than once. So here we have 3 different measures of average. We have 3 different measures of the middle of this group. We've got a 21.63, a 22, and a 24. Which one's best? Which one do we use? Well, it depends on a lot of factors, right? I don't know if there's many outliers here. I mean, you've got a 13, somebody failed the test, and a 16. If you knew that 13, there was a reason why that person failed, like they didn't show up a whole bunch, and they really probably shouldn't be included in this data because they're not giving you a fair idea of how they did on the tests, and maybe you wouldn't use mean in that case. But if that student honestly was like showing up and trying and just like not getting it or not understanding or not doing the work, then you'd want to keep that number in there. And then maybe mean would be a better bet. So you got to keep an idea of what your actual numbers are and where they came from before you can choose which measure of central tendency to use. So did his sample lead him to make a false prediction? Remember, he looked at the first 5. 1, 2, 3, 4, 5. Here's your first 5. Well, let's see what the average of those is. 18, 18, 15, 19, 20. I'll calculate that real quick here. Much easier to do an average of 5 numbers. 18 plus 19 plus 18 plus 15 plus 20. And I have 5 numbers divided by 5. So he's thinking his average mark is going to be an 18 out of 30. And if you look at the whole class set, none of these is an 18 out of 30. If you use the mode of this data set, it's an 18. Again, really low. If you use the median, cancel out the 15 and the 20, 18, you still have an 18. 18 is your mean, your median, and your mode for his sample set, which are all really low compared to the rest of his data here. So, skip too far. Does Mr. Smith's sample lead him to make a false prediction? Yes. His first few were significantly lower. Than the rest of the class. Now, does that make sense? Why would his first few all be lower? There's actually a reason for this, and it's kind of a trend I notice sometimes as a teacher. Usually, your top marks are at the very bottom of the bin or the very top of the bin, and for 2 different reasons. The very bottom of the bin are people that I know exactly what I'm doing. I'm going to burn through this whole test and hand it in 10 minutes. They're usually very confident because they usually know what they're doing, and that's why they end up at the bottom of the bin because they were the first ones handed in. Flip side of that, a lot of times the ones near the top of the stack are people that are perfectionists. They know what they're doing, but they're going to double check every answer 14 times until the bell goes and they're out of time. So a lot of times near the very top of the stack, you also have excellent papers. But in this case, his first few, the ones at the top of his stack, were all lower than the rest of the class. Maybe that's because he didn't have people double checking their work, and the only ones left were people that couldn't figure out any of the questions. They were really struggling, so they were stuck with it, and so they were just like looking at the same question for 10-15 minutes till the bell went, and then they had to throw it on that bin, and so they ended up at the very top of the list. So maybe there's a reason why that wouldn't be a great sample. There's a reason why that set of data might not represent accurately the entire class. If you wanted a better representation of the class, maybe you pull papers out of the middle of the stack, right? That way you're probably like, okay, I'm getting rid of the outliers of people that burn through a test and just hand it in. I'm getting rid of the outliers of people that can't even finish the test because they don't know what they're doing. I'm just going to look at what would make an average mark be. People that kind of know what they're doing, might struggle a bit with some of the questions, but might be able to puzzle it out. So there's reasons for this stuff too. Example 3. Youth Association surveys its 400 members about their preferred activities. Now they've split these members into 4 groups. You got the red group, the blue group, the green group, and the yellow group. And in each group, they just put 100 people. So the activities they chose from a youth activity resource, and they just kind of asked the groups, do you prefer swimming, rock climbing, watching movies, or bowling? And here's the results. So A, what is the probability that a member of a red group will choose swimming? Based on this, predict how many of the 400 members will choose swimming. Now, before we can answer this question, we have to chat a little bit about theoretical versus experimental probability. There's 2 types of probability. So, theoretical probability is if chances are all even. There we go. Chances are even. Now, this works really well for something like flipping a coin. What's the probability of getting ahead? Well, it's even on either side, and there's only 2 options, so your odds are 1 out of 2. The theoretical probability here, there is 1, 2, 3, 4 categories, so your probability of choosing swimming should be 1 in 4, right? If your odds are all even, theoretically, 1 in 4, or 1 out of 4, so often written as a fraction. Now, we know that a lot of times people have preferences. If there might be preference involved, or chance, or something random that could throw it off, what you do instead of just looking at, well, let's say it even, see what happens, what you do is you do an experiment. And you actually use the experiment. Now, if you wanted, what are the chances of flipping a head on a coin? You probably know that the chances of this happening one way or the other are pretty much even. It wouldn't make sense for you to grab a coin and actually flip it 1,000 times and record those experimental results and say, oh, the odds are 642 out of 1,000. I mean, that would be really weird. It should be close to 500, but you know what I mean? It doesn't make sense to run an experiment in that case. In this case, though, we're looking at people's preference as to what activity they like. Doing an experiment, aka asking a survey, makes the most sense. So what was red team's experimental probability? What was the probability from the experiment? We're looking for swimming. So in red team, there were 14 people swimming and 100 in total. So 14 out of 100. Or, yeah, times 100. Whoops. I times it by 10. Clear that. So that's just 14%. Percent means out of 100. I probably didn't need to punch all the math in there. So the theoretical probability is 1 in 4, which is 25%, because there's only 4 categories. But it doesn't make sense to use theoretical probability in this case because we know some people have different preferences. So we do a survey, we check it out, and experimentally it turns out that 14% of red team like swimming. Now, what assumptions are we making here in this probability? Well, we're assuming that the survey question was fair and unbiased. If we want these results to be accurate, that survey question better not be like, hey guys, swimming sucks. What's your favorite extracurricular activity to do? You know what I mean? Like, they better have a fair and unbiased question here. We're assuming that was the case. And we need to now predict how many of the 400 members will choose swimming. So theoretically, well, what's 25% of 400? 25% of means multiply. So theoretically, 100 of them should have picked swimming. If we use red team's results, though, our prediction would be 0.14 times, this thing doesn't like doing decimals. 0.14 times 400. We're thinking that experimentally we should have 56 swimmers. Now, what assumptions are we making? Not only the survey question was fair and unbiased, we're only looking at red team. So we're assuming that red team is a fair representation of all the other teams. Like if we're assuming they're kind of evenly distributed, right? If red team was all boys and blue team and all the other teams were all girls, well, that might change what they're interested in, right? Just based on whatever gender roles and experience they had. If red team were all members of sports teams, that might change what extracurricular they're interested in if the other groups were not. If red team was all anything, really. If red team was not similar to the other teams, then using them as your sample would not be fair. So we're going to assume here that red team would have to be a fair representation. Otherwise, why would we use them as our sample information? So we're thinking 56 people. Based on the survey results. So forget red team. Look at the entire thing. What is the probability that any team member chooses swimming? So now I got to look at everybody. So I got 14 plus 11 plus 27 plus 13 equals, I got 65 people out of 400 in total. So 65 divided by 400 times 100. The actual probability is 16.2. Oh, I'll show that math out here as well. So the actual probability is 16.25%. Compare your answers. Why are they different? Well, let's take a look. Why is our probability slightly higher for swimming for the whole group than for red team? Well, what do you notice about this information? What I noticed right away is green team. Oh man, green team has, a bunch of swimmers on it. So they're throwing our numbers a little bit higher. So if you were to look at the average across everybody, because green team has people that love swimming, that's going to throw things off. Also, look at red team over here. Red team has nobody that likes rock climbing. The rest of the group, lots of them like rock climbing. So using red team as a sample might not have been our best bet because they're not that similar to everybody else. That being said, we probably did better with red team than we did with green team, right? If we took green team, everyone would be swimming and nobody would be bowling. I mean, red team has a lot of bowling, which is probably a little bit out of proportion there. But here's the weakness of a sample, right? The sample is random. You might end up with you're likely going to end up with certain things favored a little bit. The bigger your survey is, the bigger your sample is, the better your data is, and the closer it should get to average. So in this case, we only looked at 25% of the people, and we missed the fact that a lot of swimmers are on green team. So compare your answers. So we could say the group likes swimming slightly more. I mean, it's really close. 14% to 16% is not a big deal. You could probably use those numbers to plan activities and you'd be just fine. But the group likes swimming slightly more than red team. Mostly because green team was an outlier. An outlier means a number that's too big or too small compared to all the other pieces of data. So it was way bigger than everybody else's. It was an outlier for liking swimming. So that's what brought our average up. If you look at the other ones, red team was close, right? 14, 11, 13. Those numbers are all pretty close. Our percentages would have been much closer if we would just use those three. But because green team was an outlier, because it was huge compared to the others, it's going to throw our numbers off. Oh, and that's it. We're all wrapped up. So this is the end of our probability unit. So we've talked about bias and how to avoid it. We've talked about different types of sampling and populations. Today we talked a bit about how to use percentages and experimental versus theoretical probabilities. So we're going to have a bit of review time and a little quiz on this sometime next week. So stay tuned for that. Next week? This week? I can't tell. The days are all blending together now. Coming up, there will be some review and a little quiz on this stuff anyways. But if you have any questions, you know where to find me. Send me a Hangouts or an email, and we'll figure out what's going on. So thanks for watching, guys, and we'll talk to you soon.